In this video, we're going to take a look at the difference between ionic bonding and molecular bonding. And so we're going to start with ionic bonding here. So if I have a lithium atom and a fluorine atom, it's kind of defined that the extra electron that's here will travel over to the fluorine atom to complete the octet. Because what's going to happen is we're going to get a full octet once this is by itself, and this completes the octet over here. So the valence shell is full. And so what we get is we get a lithium ion and we've got a fluoride ion. You can see that electron here completes the octet, and both of these ions are quite stable. The opposite charge for the lithium and the fluoride is what holds it together. So this positive charge and the negative charge attract one another, and they create the ionic compound lithium fluoride. Now, lithium fluoride is going to be a crystal, and essentially it's going to have a 3D structure of positive ions and negative ions in three-dimensional space, and we call that a crystal lattice. Because all the positives are attracted to all of the negatives, it ends up having a fairly high boiling point and a very regular structure. So it's got a crystal structure that is specific to those two ions trying to get as close to one another and organize themselves so that the positives are close to the negatives and is spaced out from the other positives as they can. So that's ionic bonding. But molecular bonding is different. If we look at molecular bonding or molecular substances or molecules have shared valence electrons. And so they still want to have a full octet, but now instead of transferring, the nonmetal atoms are going to share the electrons. So molecular substances are made out of two or more nonmetal atoms bonded together with covalent bonds. So here I've got a fluorine atom. And a fluorine atom is not actually very stable by itself. We've been drawing it like up here, we said, oh, we've got a fluorine atom. They don't really exist by themselves very well because they're so very reactive. But a fluorine molecule is something that does exist, and it's very, very reactive, and it's F2. So that's a fluorine molecule. And if you find fluorine in nature, it is going to be diatomic or have two atoms bonded together. And so this other second fluorine is going to share its electrons with this fluorine. And so they share an electron here, and it completes both fluorines' octets. Because now this has 1, 2, 3, 4, 5, 6, 7, 8. But then this one has 1, 2, 3, 4, 5, 6, and it gets to count these again, 7, 8. So they both have full octets, and it's quite stable. This is a what we would call a covalent bond. So we have the valence electrons being shared. It is also possible to get a molecular substance like hydrogen fluoride gas. And hydrogen fluoride gas will have a hydrogen, which has one proton, and it's going to share its electron here. Now, hydrogen fluoride gas has this covalent bond that looks similar to what we saw over here, and it stays as a gas, but if we dissolve that in water, it'll actually become an acid. But as long as it's in the gaseous form, it's just a molecular substance. So molecular substances have these covalent bonds, whereas ionic substances have the transfer of electrons from the metal to the nonmetal. And so the metal is the proton or the electron donor, and the nonmetal is the electron acceptor or receptor, and the opposite charges hold them together. Hopefully this helps you make sense out of the difference between molecular substances, which have shared valence electrons. And ionic substances, it is possible to have molecular elements or molecular compounds.